Hello dear students, today we are going to start the one more new topic, that is the circles. So already from the 5th standard onwards you are learning about the circles. What is the circle? So circle is a plane figure. So circle is a plane figure, the collection of all the points at the fixed distance, the collection of all the point from the fixed distance, whatever the fixed distance, from the fixed distance, the collection of all the points in the same plane. So that we call as a circle here. So collection of many points at the fixed distance from the fixed point, so that we call as a what circle here. So if you considering O as a fixed point, so then these will become as a collection of points from the fixed distance that we call as a R. So that is, fixed distance is only the radius of the circle. So these all are the basic things already you know about that one. So I will not explain about that one. Just I will go for the whatever there in your syllabus. So circles definition you got. So then today we are going to study about the tangent to the circle. What is the tangent? You are hearing the new word here. So what is a tangent here? So this tangent word came from the Latin word. So Latin word which means tanger. So tangent means that came from the Latin word tangent here, which means to touch. So which means to touch. Which means to touch. Just to touch that one. So tangent is the Latin word which came from the Latin word tanger, which means to touch, and it is given by the mathematician, Danish mathematician Thomas Fenwick in 1583. So which is given by the Danish mathematician Thomas Fenwick in the 1583. So this is the basic knowledge about the tangent. So this is not for examination purpose, just for information purpose this one. So tangent word came from the Latin word tanger, and which is given by the Danish mathematician Thomas Fenwick in 1583. So then what is the tangent now? Just only by the meaning of that Latin word we got just touch. The tangent to the circle is the line intersecting the circle at only one point. The tangent is one line that intersects the circle at one point. So if you are considering this as a circle with center O here. So tangent is always drawn to the circle only. So this is a circle, and tangent is the line which just touch or intersect a circle at one point. At only one point, it has to be intersect the circle at only one point. So not except more than one point here. So that has to be intersect the circle at one point only. Sorry, here. What? Tangent is the straight line, which is the line which just touches the circle at one point. Just touching the circle, intersecting the circle at one point, that we call as the tangent here. If you are considering the xy is a tangent, that will be touches the circle at the point P here. Getting? So then, where the common point where the tangent and circle will be intersect, on that common point we call as the point of contact here. The common point of the tangent and a circle is called as a point of contact here. But now the tangent to the circle is line which intersects the circle at one distinct point here. So if for the circle, how many tangents we can draw? Infinitely many tangents we can draw. But for at only one point, from the one point we can draw the only one tangent. So here, considering the point P, if you want to draw tangent from this point P, we can draw only one. So if you want to draw another any point, so wait, I will show one by drawing diagram here. So here, this is a circle with a center O. If you are given a point, here we draw one tangent. Except this, at the same point we can draw one more or more than 4, 5, 6 or infinitely many tangents, try here. So if you want to draw, so no. This is also no, or like that you can take. So what will happen? They are not a tangents. They are, so here, if here also this, if you are considering this one point line here, so this will be intersecting at point P also, but it will be intersecting the circle at another point also here. So what will happen? Whatever the lines except that XY line we are taken, they will intersecting the circles except that point, another point here. So except they intersecting the circle at 2 points here. So means for the given point we can draw only one tangent to the circle for the given point. If you are drawing more than 2 tangents, if you are trying, means that will be not drawing as a tangent, you are drawing there as a secant. What is a secant then? If the line will be intersecting the circle at the 2 points. So that we call as a secant. That we call as a secant. Getting? So tangent means the line we have to draw at the one point only. They will be intersect the circle at one point. If you drawing if they given as a point P only, if the circle here they given only one point, that is R, draw tangent to point R to the circle, means we can draw only one tangent for that circle. If you are trying to draw more than one tangent to that one, so that will become a secant, that is not a tangent there. So we can draw only one tangent for that one. And whatever the tangent drawn to the circle, whatever the tangent be drawn, wherever also you can draw. So drawn to the circle here, if you are at a point P, drawn a tangent to the circle, this tangent is always perpendicular to the radius which drawn from the center. The line which is always perpendicular to with respect to the center here. Getting? That point of contact is there, that and radius, whatever the line will draw now, so that is always perpendicular to that radius here. So if you can take here to the ground floor, so there also it will become perpendicular. If you take here, then also point of contact and the fixed point. So whatever the radius we drawn from the point of contact to the fixed point, now that will be perpendicular to that tangent here. So depending on this, we can prove the theorem here. So here the theorem on the circles here and tangent. The tangent at any point of a circle is perpendicular to the radius through the point of contact here. So just only I told the radius through point of contact is perpendicular to each other through radius and tangents here. So if you consider a circle with a center O, here circle with center O you have to draw here. So again what they given, circle with a center O and what you have to take, tangent. So tangent you can give name as a XY and the point of contact you have to give name as a P here. Okay, so this is a circle and tangent to the circle here. So then given, write down first, given a circle with a center O, a circle with the center O and a tangent XY, a tangent XY. So tangent XY to the circle at the point what here, at the point P, at the point. So this is a what given here, at the point P only the tangent is touching the circle, yes or no? So there only P is a point of contact here. So then this is a given. To prove, what are they told to prove? Radius is radius, which is the radius, OP is the radius of the circle. This OP is perpendicular to XY. What we have to do that? Radius is OP is perpendicular to XY. Yes, so then perpendicular to the radius through the point of contact. Perpendicular to radius XY, tangent is perpendicular to the radius of XY. Otherwise, we can prove that XY is perpendicular to OP. So like that also you can, XY is perpendicular to OP here. XY is the tangent, OP is the radius of this circle, that we have to prove. So you have to do a construction here. what we have to do the construction. So choose any point on the xy line except P. Except P, any one point you have to take. So that I will take here it is R. R. So then you have to join O to R here. So this is the construction we have to draw this by dotted lines. So then that line will be intersect the circle at the point Q here. Okay. So construction, choose any point on tangent except point P. Except point P only we have to choose, except point without, because we want another point on the way. If you take a P only on that means it will become. So you have to join any one other point you have to other than P. Tangent, because choose any point on a tangent other than P. Other than P. Other than P. And join it. Join OR. Other than P to then join OR. Join OR which intersect circle at point Q. This Q point is important here. At point Q here. So then here given over to prove whatever over and the construction is over. So then come for the proof. Proof, what is the proof here? So what we have to prove? This xy is perpendicular to OP, that we have to prove here. So then here already we know that one OP and OR are both are the radius of the circles here. So means we can tell that OP and OR are equal because of the radius of the circle here. So then all the line segment of point O, OP, OQ and OR. So we have to consider all the line segment we have to think about here. OP and OQ both are equal here. So then we have to prove that OP is perpendicular to XY, that we have to prove here. So then what we have to, we know that when OP is equal to OQ here because radii of same circle here. OP is equal to OQ because both are the radii of this same circle here. But here what we have to take, whether both the OP and OR is both are the radii of the same, OQ are the radii of the same circle and OR is greater than OP here. But we know that one, but OR. So OR is equal to what? OR, OQ plus QR. OQ plus QR here. So but OQ is OP here. Yes or no? OQ is OP. Both are equal here. So then OP and OQ are both are equal. So but what we are taking here, OP and OR only we are considering here. So when OR is equal to OP plus QR. So because OP is equal to OQ here. So then AP and OQ are both are not equal here. So it gives that therefore what here? So OP and OR are not equal. OP is greater, OR distance is more than the OR here. So OP is little bit more than the OR here. Yes or no? So then we can tell that here OR is greater than, OR is what? Greater than we can take. So OR is greater than OP here. OR is greater than OP. So what will be happen except B point in all the cases, wherever you can take, the radius will become a more only. Only in the point of P, the radius will become perpendicular here. The distance of OP is greater than the OR for any intersecting points here. Any intersecting point you can do 6. So since this happens for, this will be happens for since this happens for every point on the line xy except the point P here. That will happen for every point here except the point P. That will be happens in every point here. So therefore we can conclude that OP is the shorter than OR here. So therefore OP is shorter than OR here. So OP is shorter than OR means we can conclude that OP is perpendicular to XY here. So we can conclude OP is perpendicular to XY here. So this is the theorem depending on the circles here with contact to radius. Here what we can tell that tangent is always perpendicular to the radius at the point of contact here. So this is the theorem 3.1, very important theorem. This will be asked in exam for 3 marks compulsory. 2 theorems are there, in that any one is compulsory for you. So here number of tangent from a point on a circle. So how many tangents we can construct by the given point here? So we will see the 3 cases. First case we will see here. So here we are consider a circle with a point with the center P here. So in the first place I will take a point that is inside the circle. So whether if the given point is the inside the circle, from that we can construct the circle because that is the interior section here. So then see, try to draw the circle tangent here. So whether it is possible to draw a tangent to this circle here? No. So because whatever the line passes through the given point, that will be touching the circle at the 2 points here. So if you considering 1, 2, 3 lines, first line you consider that will be intersecting the circle at the 2 points here. So if you consider second line, that is also intersecting the circle at the 2 points. If you consider third one, that is also intersecting the circle at 2 points here. So means if the given point is inside a circle, so due to that one we can't construct a circle to the tangent here. In the first place there is no tangent is formed to this circle here. So in the second case, if the given point is on the circle, so given point is on the circle, so then how many tangents we can serve? So then check out so we can construct it 1. So one tangent we constructed for the given point. You can take name as a P here. Okay. So then try to draw one more point. So no, it is not a tangent because it will be intersecting the circle at 2 points. So try to draw one more. So no, that is also not. Here also it is a touching the circle at the point. So means if the point is on the circle, means we can draw only one tangent from that point to this circle here. If the given point is on the circle, means from that point we can draw only one tangent. So in the first, inside the circle there is a no tangent. So on the circle means that we can draw one tangent. If the given point is outside the circle, so if you consider P, yes, okay here. So then how many tangents we can draw from that point? So check out, tangent means that has to be touch the circle. Yes, one is okay here. So you can take one more. Yes, this is also possible. 1, 2 over. So here first one tangent 2. So whether try to take one more. No. So this side, that is also no. Here nearby that also you took means that is also take a 2. So except that anywhere, so no. Middle means that will be passes. So means what? If the given point is outside the circle, from that how many tangents we can draw? 1 and 2. Only 2 tangents we can draw here. So it means clear that from these 3 cases, if the given point is inside the circle, there is no possibility to draw any tangent to this circle. If the given point is on the circle, from that we can draw one tangent to the circle. If the given point is outside the circle, from that we can draw 2 tangent to this circle here. So maximum possibility this only. So then for the given circle, by taking any points we can draw infinitely many tangents. But if the due to fixed point means we can draw depending on the position of the point. If inside there is no possible, if on the means 1, if outside means we can draw 2. So just only simply they given the circle, for the given circle draws tangents. So how many tangents? Infinitely many tangents we can draw from the circle to the circle. But if they given any point, from that depending on the point position we can conclude that how many tangents we can draw from the circle here. So depending on this, one more theorem is there, means if the given point is outside the circle, whether if here from S to T, this is one tangent. So from S to T, whatever the distance is there now, that distance we call as the tangent distance. The distance from the point to circle, that we call as the length of the tangent. The distance from a point to the point of contact, that we call as the length of tangent here. That we call as length of tangents. Length of tangent. So if the tangent drawn from the outside front to the circle, whatever the two tangents we drawn, that both the tangents are equal. Both the tangents are equal. So depending on that, one theorem is there. We will discuss that theorem now. So here one more theorem, that is depending on the length of the tangents here. So in length of the tangent from the external point, both the tangents are equal. That we have to prove here. The length of the tangent drawn from an external point to the circle are equal. That we have to prove that PQ and QR are equal. That we have to prove here. So this is a circle with the center O and the point external point P, and with that we have drawn a PQ and PR are the tangents. We have to prove that PQ is equal to PR here. So that we have to prove here. So then first we have to write down the given. What are the given? Circle with the center O. Circle is with the center O, and P is the external point. P is a external point tangent to drawn from the external point. We drawn a P is a external point here. That is outside the circle. So P is the external point, and two tangents PQ and Q. PQ and PR. PQ and PR are the two tangents. So this is a given. So then we have to given over to prove. What we have to prove here? So we have to prove PQ is equal to PR. That we have to prove here. PQ is equal to PR. That we are going to prove here. So then construction. What we have to do a construction here? Construction is very necessary. Without construction we can't able to prove the statement here. So we have to draw OQ, OR and OP. Join OP, OQ and OR. So all points we have joined here. So perfectly one shape we got here. So then proof. So while joining the OP and OR and OP, what were the first two triangles we got? That is the triangle PQO and triangle PRO. So then both are the right angle triangle at Q and R, because here radius is perpendicular to the tangent. See, already we know that one radius is perpendicular to the tangent, or tangent is perpendicular to the radius. You can from the previous theorem here. So then proof. Consider the two right angle triangles, or two right angle triangles PQO and PRO. So you are considering PQO and PRO, two right angle triangles. So in that, which is OP is a common, and QR OR, OQ and OR. So here OQ is equal to OR because radii of the same kind. Because radii of same circle, radii of the same circle here. So both are, so here OP and OP. Common here, OP is common for both. So OP is equal to OP because of common side. Because this is a common side for the both the triangles. So next one here, angle PQO and angle PRQ both are right angle. Yes, both are 90 degree. Yes, angle PQO that is equal to angle PRO because of 90 degree. Each 90 degree because of each are 90 degree. So by considering 3 we can conclude that triangle PQO is congruent to triangle PRO because of theorem RHS. Because of the RHS. Right hypotenuse, right angle, hypotenuse and other one side. So here right angle, this is a 90 degree, hypotenuse OQ that is also equal. Right hand hypotenuse and other two sides which are the PQ and PR are equal. So sorry, OQ and OR are equal here. So therefore both are equal means by the CPCT. By the CPCT we can conclude that OQ is equal to what? We have to prove that PQ is equal to PR because of CPCT, corresponding parts of congruent triangle here. So this is hence proved here. Hence we proved this one here. So because of CPCT, if all the corresponding parts of the congruent, if these two triangles are congruent, automatically PQ and PR will become equal here. So this PQ is equal to PR because of the corresponding parts of the congruent triangle here. So two theorems are there for any one. Otherwise, they will give in the choosing purpose. Both the theorems they will give, you have to solve any one. All questions they will give. So, both any one of the theorem is compulsory for 3 marks. Very important, both the theorem you have to perfect the theorems. Very easy theorems are 3 marks in your pocket only. So, these are very important. They will ask, definitely they will ask for the 3 marks. So, depending on these examples we will solve in the next class here. So, I hope you all getting these two theorems. Very important. Practice again and again. Very important for the examination purpose. Thank you.